Yeah, okay. Good morning once again. I will share the screen now. We'll start our lesson today. Just a minute. Yeah, join. Okay. Just share the screen. One minute. Right. Now, okay, back here with the lesson. In the last class, we are discussing on a definition of a data structures, and I have told you how a data structures is there and what is a data and what is the importance of a data. So data is the figures and facts and basic elements, how we can arrange that to make an information, and after making an information, how we can give an information. Everyone mute, please. Everyone, mute, please. Yeah. Now, so then I've told you that somebody is still mute this, mute everyone. Sugandhini. Why she left? Something problem. Okay, we'll start. Yeah, as I told you that how a data is very important, and I have shown you the pyramid of that particular data and how from a data, facts and figures, from there we'll make an information and finally, when we come to the data structures, the one by one we have taken into the consideration. Data, okay, data is there. Assume my data is 10. Where I want to store that particular data? I need a place. I need a place to store the data. As I give an example of an kitchen groceries, how your mother will store in a separate jars. Why she will store in a separate jar? She will keep in one particular place. While cooking, it will be an identification for her. It will take and she will take and she will cook the food. So like that, we have taken an example in a last class and have told how a structured arrangement of a kitchen will be made by your mother. Like that. Sorry. To retrieve the data, we have to make the structured data. The data in a memory we have to keep in one particular format. Then it will become a structured, and then from there you can take out the data and we can handle that particular data easily. That I have told you. Coming to the next, the things here as a primitive and a non-primitive. Now, what is a primitive? So this question arises always. Now, assume in last class I have told you that there will be a memory like this, and I want to store a 10 value here. And a 10 value I'm storing somewhere here, where I should store here. Okay, assume that I have stored somewhere the 10 value, and how to retrieve that value. How I should know that where this value is stored in this vast memory? Why? Because always, sorry. Yeah, always memory will be identified with an bytes, right? So each byte will have its own ID, and the sequence of bytes will be there. For example, if I tell, you can imagine how vast the memory will be there. Now today we are using 6 GB of RAM, 8 GB of RAM we are using. So in a GB, if you consider how many bytes of memory will be there, so in a large together, so that bytes of a memory, each byte will have its own ID. Then how to identify that particular ID? Then how the arrangements of a memory will be there? So that is another one very important question arises. So when we come to the data structures here, there are two types of data structures. The basic things will be there. That is a primitive primitive, and another one is a non-primitive. So what is a primitive data type? The primitive data type is a one, so where you can store a single value under one identification variable. For example, memory addresses is there in a hexadecimal. Everyone, you should remember these addresses. If I tell, no one will use a computer. Why? Because that many lakhs together of an addresses, how are we any human being can remember that particular thing? So what we will do, I will define in a variable, and in that variable place I will store the value. So for example, in a C programming, when I will declare it as an int a, assume for example int a, then what happens in a memory? In a memory, for a, under a, 2 bytes of memory will be reserved always. So 2 bytes of a memory will be reserved, and this byte I'll call it as a 0, and this byte I'll call it as a 1. Why below to above I've given as a lowest bit significance identifications will be there in a memory. That you have to keep in your mind. So always a data starts filling up with first identification of this address. So the 0 byte address will be there stored in a A. A will be represented with this particular address. That we'll call it as an ampersand A. If you want the address of a variable, always will go with an ampersand A. That you know, you have did already C programming and all. So in a scan, if you are going to give ampersand A, percentage D, so like that you are going to give. Why you are giving like that? I am storing an integer value in this particular address. Once you have told integer value in this address, already reservation has been done in a declaration part itself. While storing, how it will come, so ampersand A, automatically it will comes to this address, and you have told that you are storing an integer value. That means another byte is also there, so it will take another the next byte which is there in a sequence. That is a 2 bytes, so it will start storing here. This is a sign bit, and it will start from right to left always. So in this way the value will be stored. Okay, for example, if I tell you like this, int a I have declared, and I want to store two values 10 and 20. Can I store in that? Can I store in
No, sir.
that 10 and
No,
20?
sir.
No. Why? Because you will tell, sir, you have declared only one variable, and at a time you can store only one single value. So that is a primitive data type. Any data types you can take, that is int a, int you can take, char you can take, or you can take the float also, and different types of this extensions, that is a long int or a string or a double. So whatever static, whatever is there, you can take on this, but only a single value you can store here with this identity. This is structured. This is structured. You have to keep. I'm not storing a data without any identification. Storing a data with identification in a memory is a structured way. So that is called as a data. Even your primitive is also in a data structure. So here, what is the problem means I can store only a single value. Coming to the next, the non-primitive data structure. Here, non-primitive data structure. What is a non-primitive data structures? Assume if I want to store more than a value. If I want to store more than a value, for example, I want to store a set of values under one identification. So how I can store that particular values? So so whenever we will store a multiple values in a memory under one particular variable, and you will retrieve using a reference of the first byte all the values, other values also, that is called as a non-primitive data structure. For example, I will tell you, you can take here a set of values, whatever it is, Q, array, and list, whatever is there you can take. So best we know already the array. A of 10 I will take. What is this? What is this A of 10? Once I declare this A of 10, what it will do? In a memory, same in a memory, right? In a memory, like this, 20 bytes will be reserved. 20 bytes will be reserved. Why 20 bytes? You know that for an integer 2 bytes space is required, and I am told that I need a 10 values I want to store. So automatically 20 bytes. Why? Because 10 into 2, 2 bytes is required for integer. So whatever a last significant bit, so this I call it as an zero, assume for example. Okay. Now, here same thing like ampersand EA will be there, right? And the address of this particular byte will be taken here. Now, what is a non-primitive data structure here? The non-primitive data structure, how I will retrieve the data, that is very much important here. So how I will retrieve the data, if I have a first value, then automatically I can get all other values easily. For example, if I get a zeroth value, then automatically the 1th value I can get like that. I can get automatically one by one. So this is a non-primitive data structure. Now I'm concluding this. The primitive data structure is a one where you can store a single value and you can retrieve that value under one variable. What is a non-primitive data structure? Non-primitive data structure is that under one variable you can store a multiple values and you will retrieve the data using a reference of the first byte or a reference of that particular variable. So this is the non-primitive data structure. Any doubt is there, you can ask me. Any doubt is there here?
No, sir.
Any doubt?
Yes,
Clear?
sir.
Yeah, coming to next, we will deal always with non-primitive data structures more rather than primitive data structures. Primitive data structures already you have gone through the degree, the C programming, Java, like that. You have been and you know how to use the variables and all. Now here non-primitive data structure. Here non-primitive data structure again two types is there in a non-primitive data structure. One as a linear data structure and another one is a non-linear data structure. So both are non-primitive data. That means you can store a multiple values. What is a linear data structure? Linear data structure is the set of values what you are storing in a memory. You will store in a sequencing order. In a sequencing order. Once if you start retrieving the first value until the n value in one shot, you can retrieve all the values one by one, like this. Never you will stop in between. So that is called as a linear data structures. For example, I will tell you here, for example, array, right? And another one is you can take a cube and you can take even a stack and you can take your linked list. Linked list. How I linked list? See, everything I'll tell you. Here, if I get the address of the starting byte, automatically one by one, I can retrieve without stopping until the last element. So that is a linear data structure. So how it will be? Why? Because all the elements, whatever stored, will be one by one. It will be in a sequence order. When it will be in a sequence order, I can take out easily and I can retrieve the data easily. So that's why I will call it as a linear data structure. Any doubt is there here? So linear. This is a linear data. Coming to the non-linear data structure. Now, in a non-linear data structure, there are two are there, that is in a graph and another one is in a tree. So this is a non-linear data. That means while you traverse with this data structure, traverse means retrieving, traverse with this data structure, you can't take out the elements continuously until the nth element. Why? Because you have to stop at one particular stage. That's why we'll call it as a non-linear. The elements will not be in a sequence. The elements will not be in a sequence in this data structures. For example, you take like this. Just I will do A, B, C, D, and E, F, G, just for your clarification. Assume now this is a tree which I have taken. Why I am telling this a non-linear means it's not one by one. For example, I will Traverse, I want to
Sir, there is
traverse.
issue, sir.
Tell me, Pa.
Sir, Darshan is not unable to connect to the class, sir.
1 minute. 1 minute. I'll allow him. 1 minute. Yes.
Okay, sir.
He's asking?
Yes,
Yeah,
sir, he
yeah,
is asking.
yeah. Admit it. Admit it.
Okay, sir.
Admit it. Ma. Anybody others are there? You tell me like that. Not issues.
Okay, sir.
Okay?
Okay,
Okay.
sir.
Okay. Now again, sorry. Yeah, now again, assume that from A, I will go here, I will retrieve B. Okay, from I will B, I will come back and I will retrieve C. From here I came to end. This is a end leaf, right? But again I should go back to B, again I should take D going back. This will tell that the whatever is the elements are there, it's not in a sequence. But when you take an array, now I will take an array. Assume assume this array 10, 20, 30, 40, 50. Just for a second. I will retrieve 10. After that increment I will retrieve 20, 30, 40, 50. So why? Because this 10 to 50, they are in a sequence. Sequence word is very much important here. Linear means the elements should be in a sequence. Here it will be in a non-sequence. Okay, why? Because at a time you can't retrieve, you must have a break, you must go back, and then you must come from back again. Like that you have to do to retrieve D here. But to retrieve G, what you have to do? Again, you should go back. A, again you should come to E here, then afterwards you should come to G. If I want to retrieve F, again I should go back here. Like that, this reverse thing we have to do, but in a sequence, there is no such a need. So that's why linear and non-linear. Two types of data structures will be there. Even if you consider queue also, you know queues means in real time also, you know queues one by one sequentially will be there. Always one after one work, second person will come like that. Even stack, I will tell you about a stack and all. So LIFO method, this also in a one by one sequence. Even a linked list is also in a sequence which we are going to work. Only two data structures, that is a graph and a tree, are the data structures will be there under a non-linear data structures. Coming to the next thing. Just I will put another one sheet here. 1 minute. Yeah. We'll go to next page. Yeah. Coming to the next the next thing, whatever is there here. So once you have declared the linear and a non-linear data structures, we'll go with the linear first, and we'll discuss how linear structures will be useful for us. Now, coming to the array, we'll take first as an array, and then we'll come with a stack, and then we'll come with the applications of a stack. And afterwards, we'll discuss about the recursion functions, then after about a queue, and after about a linked list. That is your syllabus, actually, to say. That is your three modules of the entire thing. Means data structures. Coming to now, the first thing, array. How will you declare an array, and how will you store a values in an array, and how you are going to retrieve the array and all that will be there. For example, assume that in a C program, I will declare like this: int a of 3. Just for a sake, I'm taking int a of 3. I'm going to take. Now, int a of 3, once the compiler will execute this particular statement, then automatically a memory will be created like this. Right? Assume that each space is of 2 bytes. 2 bytes. But in ANSYS, you have to keep in your mind. Sorry. In ANSI, when you work on Linux, when you work on Linux operating system, it will be of 4 bytes. Why? Because in lab you are working on a Linux operating system. That differences you must know always. Which int will have the 4 bytes, but in ordinary C program, Turbo C and all, when you do int will have an 2 bytes. That you must keep in your mind. Now assume 3 values. So 3 values it will take. So from here, assume the values. So I will 10, 20, 30 just for a second. Right. So this space is reserved. Values will not be there. Don't worry about that. So now here it will start with this address. For example, I'll write this as an X101 just for a sake. In a hexadecimal way, it will be there. Just for a sake, I'm writing this. Right. Now, once you declare without values, this 3 bytes into 2, that is 3 to 6 bytes will be reserved within a starting byte. The 0th byte will be like this. Assume. Now coming to the next statement. What is the next statement? Okay, I declare now I want to input a values to the array. How I want to input a values to the array? This always be a thing. Always the sequence of the elements. Why? Because array is a linear and one by one we are storing. So if I take one index variable, so if I start with 0 and next element as a 1 and next element as a 2, next element as a 3, then automatically if I increment, then I can store the elements easily, right? So how we are going to do that? For example, first you will go with an index element for I is equal to 0, I less than n is important. You are starting from 0, I plus plus. Now I will tell here scanf ampersand a of I, right? Percentage d. Close this. Now ampersand a of I percentage d, close this. Now when I execute this particular statements, what happens? Initially I value will be equal to 0. Am I right? And assume this is your array here, a. Now, when the statements executes, I value is 0, condition will be there here, I'll write a condition, right? So 0 is less than, what is the n value? You declare a n value here, that is n is equal to, I want to store a 3 values, so 3. So n 0 is less than 3, condition is true, you are getting into the for loop. Then what happens? Then ampersand a of I, this is very much important here, you have to identify this. I am not telling a, I am not telling a variable a, I am telling my compiler very clearly that ampersand a of I, ampersand means address of a variable. I am telling that you go to the address of a of I value is 0, that means a of 0, you go to the first 0th element, first byte, 0th element, first byte is 0x101, so this is 0th and 1 is there here, and 2 and 3 is there here, like that. So next, it will come here, it will see, yeah, it's correct. So this is correct. So once it is correct, the 2 bytes space will be taken out from this, and I have to, why 2 bytes it will take always? I have told percentage d, this is important here. Why percentage d? Percentage d I have told. So that's why automatically it will come here. If you doesn't give this, you will get an error. Am I right? Am I right? Maybe it's a
Yes, sir.
simple thing you're feeling, but very important it is. If I doesn't give ampersand here, I'll get an error. If I doesn't give a percentage d, I'll get an error. If I give percentage f, again I will get an error. If I give percentage C characters, then also I will get an error. Why percentage d only I should give? I am telling my compiler that I am going to store an integer value. You utilize 2 bytes subsequently. So whichever address I have told, the next address, whatever a next byte is there, you take that also. So like that it will come and it will take a 10 here. So your 2 bytes will be taken for 10. Next, what happens? Next, I will become 1. Why? According to this increment statement. Now, again, what happens? It will come, the for loop will repeat, for loop will repeat, and 1 is less than 3, condition is true. Again, scanf, it will come here. Now, what is the thing? I'm storing a second element. Next next sequence to whatever is there. Assume 0 and 1 bytes has been filled up, and now is 2 byte address is there. Now directly it will go to that byte, second byte. So second and third will be utilized for 20. It will store 20 value. Again, the loop will 2 is less than 3. Yes, 2 is less than 3. Again, it will come. I am going to store a 30. Again, I will become 3. 3 is less than 3. Condition is false. Will come out. You'll come out. Then how to retrieve the array values for I is equal to 0, I less than n, I. Why it is coming like that? 1 minute. In my paper, it's coming correctly. Just a minute. I struck it off. Now you see, for, I should lift, I think, for each statement. 0, yeah, less than n, right? I plus plus. Okay, done. Next. Print f, I can't join. Print f, percentage d, percentage d, percentage d, a of I. Right. So when you take this particular statement, now already 3 elements are there in an array. How I am going to retrieve the elements? Same concept again here. Again, I will be there and A will be there and condition will be there. In A already I know that 30, 20 and 10 is there. Coming to here, I will be a 0th element. Now it will comes here. Condition is true. 0 is less than 3. So then it will come to the printf. Now observe carefully in a printf statement, what we are telling, I want to display an integer value. This is very much important. Percentage D, without giving this, you can't display. Why? Because you must know in depth n number of times you have typed this statement. You are telling my compiler, you are telling a compiler that percentage D means integer value. I am retrieving integer value. That means whatever this A of I means A of 0th is there, you don't retrieve from 1 byte, you retrieve from 2 bytes. That's why you are telling. Are you getting? Now automatically it will come whatever the bits is there in 2 bytes, it will take out, it will convert to the decimal and it will display for you, and it will display 10 for you. Again for loop repeats and I value becomes 1, then it will go and the next the pointer will be there at the next byte, means 0th and 1 already taken into consideration, 2 and 3. Now it will go there and from that byte again I am telling 2 integer means 2 bytes. Why? Because it's an integer. Again I will retrieve 20, again 30. So like this we are working with an array. Any doubts is there? You can ask me. Any doubt? Any doubt? Come on. I think no one is there.
No, sir.
No doubts is there. Am I right? Am I right?
Input statement.
Yes, sir.
Format specifier.
Input statement.
Ali scanf ali percentage D format specifier ge double quote ಹಾಕಿಲ್ಲ.
ಇಲ್ಲ ನಾನು ನಿಮ್ಗೆ ಅರ್ಥ ಆಗ್ಲಿ ಅಂತ ಬರ್ದಿದ್ದೀನಿ ಅಷ್ಟೇ. ಡೋಂಟ್ ಟೇಕ್ ಇಟ್ ದಟ್ ಆಸ್ ವೆರಿ ಸೀರಿಯಸ್, ರೈಟ್? ಪರ್ಸೆಂಟೇಜ್ ಈ ಕಡೆ ಬರಬೇಕು, ಆಂಪರ್ಸೆಂಟ್ ಎ ಆಫ್ ಐ ಈ ಕಡೆ ಬರ್ಬೇಕು, ಕರೆಕ್ಟ್ ಅಲ್ವಾ? ಒಬ್ಬರಾದ್ರೂ ಐಡೆಂಟಿಫೈ ಮಾಡಿದ್ರಲ್ಲಪ್ಪ ಟ್ಯಾಕ್ಸ್. ರೈಟ್. ವಾಟ್ ಅಬೌಟ್ ಅದರ್ಸ್? ಯಾರು ಐಡೆಂಟಿಫೈ ಮಾಡಿಲ್ಲ? ಈಗ ನಾನು ಕೇಳ್ತಾ ಇದ್ದೆ ನಿಮ್ಮನ್ನ ಕ್ವಶನ್, ಇದು ಎಕ್ಸಿಕ್ಯೂಟ್ ಆಗತ್ತಾ ಅಂತ. ಅಷ್ಟರಲ್ಲಿ ನೀನು ಹೇಳಿದೆ. ಸರಿ, ನೆಕ್ಸ್ಟ್. Okay, coming to the next thing, we'll go with the stack, right? So stack now, what's the stack? First, Why stack we have to study? That questions. First we will discuss, and next we will go to the next. Just I will take out the sheet. 1 minute. Yeah, coming to the next thing, the stack. Why it's writing like that, I don't know. Stack. So stack will follows always the LIFO method. LIFO or which one? FIFO. LIFO or FIFO? Both
What, sir?
are very good.
Last in, first out.
ಯಾಕೆ ಹಿಂಗ್ ಬರೀತಾರೆ ಒಂದೇ ಒಂದು ನಿಮಿಷಪ್ಪ. FIFO and LIFO. Right. So FIFO is first in, first out. It will be always with only Qs. But LIFO is last in, first out. First, last in, first out. Why it's coming like that? So last in, first out. Now coming back here. Now your stack will be there always with this particular concept. Your stack will work with always with this. What is this? What is this? Last in, first out. Best example I will tell you. I will take a plates or I will take a box. Okay. I will keep 10 books. One by one, on one by one, on one by one, like that. I will keep 10 books. Now I will tell you that I want a third book. How will you retrieve this? How will you retrieve this? Come on.
FIFO. So by removing the top book.
You will remove the top book. Why you must remove the top book? You can't take the third book directly.
No, sir.
No, why? Because in that particular whatever on one by one you have kept, sir. So there is no other way. The books, whatever is there, I have to go to the third place. Entire books I have to take at one shot, or one by one book I can take and I can place somewhere, and I should take out the third book. Am I right? Am I right? Everyone. Yeah. Now this is called as a last in, first out. Why? Because whatever you have put a last, that you are going to take out first. For example, the 10th book. Assume that I have taken a 0th book, I kept at the table, and next one book I have taken, kept on that, and 2 book I have taken, kept on that, 3 I have taken, kept on that. Likewise, I have kept, it's still 10th book. Now 10th book, when I have kept, if I want to take out the book from that particular wardrobe or from a particular space, then automatically I should take out the 10th book. Am I right? Am I right? That is last in, first out. Always the last, whatever the element you have inserted into the stack, that you are going to take out. Always the stack will be like this as a container, So this will be container like this. Just for a sake, I'll tell you. So how the last in, first out, for example, I am inserting the values like this. That is 10, 20, 30, 40, 50. Just for a sake, I am telling. Now, if I want to retrieve 20, first I should go to 50, 40, 30, then 20 I should take one. What is the stack here? Last in is the 50. You have to take that first out. That is 50. You have to take it out. Then always a pointer will be very simple. I'll tell you. You can write a program automatically once I will tell you. So like that. You can take out a 50 here. and then you can take out a 40, and then you can take out a 30, then you can take out 20, and then 10. Okay, sir, you are telling everything is okay. Then how I should know that how many elements are there in that stack, and which is the top element? How I should know? How I will come to know that? So this question arises always. Why? Because is there elements in a stack? All these questions. Then is the stack capacity? What is the stack capacity? So all these doubts will arise. For this, what I will make, I will use one pointer, a pointer as a top. So I will keep always this top as a -1. This will indicates that no elements are there in this particular container or a stack container. Right, no elements are there in this stack container. Right, one second. Why it's coming back? Yeah, okay. I will take it as a top as -1. So, sorry, top equal to -1. Now, okay, top is -1. What is this top? I will use a top as an identifier for my particular stack. For example, when I will insert an element into this particular stack, assume I have inserted 10. What I will do, I will increment my top and I will tell my top, you be here with 0 value. This is push. Right. Again, I will insert 20 element. What are 20 element I will insert? 20 I will insert. Then I will tell my top, let you be in a 1 position. Why? Because 2 elements, 0 and 1 is 2 elements. My top will become now 1. Now again, I will insert another one element, let it be 30. So I will tell my top now, you be at a 2. Why? Because you are a third element starting from 0. Finally, I will come to the 40. Then I will tell, let it be at top 3. So once, if assume only 4 elements capacity is there of my container, of my stack, so then automatically next I will check if top is equal to max. Assume the max is equal to 4. Once top is equal to that max, then I will tell stack is overflow. You can't put elements up to the user. Then how to retrieve this? So that is pop. Pushing of elements into the stack, what I did now, we'll call it as a push function. Okay, now in a stack that 4 elements are there, I have pushed that. And now top is equal to a third level. Then how to take out that particular stack, means elements from a stack. Now I will call that as a, I will call that as an pop function. I'll write here pop. So what is a pop here? Retrieving a data from a stack. First, what I will do, I will check with a top. What is this top? If top is equal to -1, there are no elements in stack. Why? Because top will be -1 always when no elements is there. If top is having some value, there are elements. Whatever may be that, from top I will keep on retrieving the elements. That means I will take out the top best element first. What is the top? Now top is 3. At third place, 0 to third place, what is there? So 40 is there. I will take out 40. And I will make top is equal to 2. Now I'll make top is equal to 2. Now my top is 2. Don't worry about 40 element. You can ask, sir, it will be there in array only. No, I know that it will be. I and you know it will be there in array. But I'm giving a program to a customer. Customer doesn't know that. Why? Because I'm retrieving based on top. Right. So now top, whatever is there, now top is equal to 2. Now what is the toppest element in your stock? The toppest element in my stock is 30. Why? Because according to the top table,
30.
Hello? Any doubt?
30, sir.
Yeah,
30, sir. No, sir.
Huh? Hello?
Okay,
Hello?
sir. Okay, sir.
Okay. Now it will be 30. Why? Because I'm starting from 0. You have to keep in your mind. 0, 1, 2, third element. Right? Top is equal to 20. Take out 30. Once I will take out a 30, I'll make my top as 1. In my stack now, how many elements are there? Now you have to answer. In my stack, how many elements are there?
One, sir. One, sir.
Huh?
10 is there. 10
How
is
many
there, sir.
elements are
One
there?
element.
Two.
Two elements.
Hey,
Two elements.
why two elements? Why two elements?
20 and 10. Top is 1.
We have stack. You have to
20 is the top.
1 and will be there.
Yes, sir.
Yes, sir.
Got it, I think. Right. Now we have to retrieve that back here. So when you retrieve that back means again now I will go to display function. If I tell display in a stack, it will displace 20 and 10. Why? Because I have popped 40 and 30. Now in stack, how many elements are there? Two elements. Assume that again I will push. Now in this stage, I will push. What I will push? I want to enter again 30. What I have to do now? What I have to
So
do?
increment the index value, sir. It will increment the top.
Very good. Increment the top. Now again top is 1. I'll increment the top to 2. Top is equal to
2.
2. Now again I will put 30 here. Now what is the top value? Top value is
2.
top value is 2 and 3 elements.
2.
Hello? Aitappa?
Yes, sir.
Yeah.
Yes, sir. The top value is 2.
Yes, top value is 2. 3 elements are there in a stack. Right. Now if I tell display, how many elements will display?
3 elements.
3
3
elements.
elements, that is
Yes, sir.
Yes, sir.
Yes, sir.
okay. Now, so I will end here. Let I have given a glance of this stack to you. In the next class, I will show an animation of a stack to you. And later on, we'll go with the coding of the stack program. Okay? Okay.
Okay, sir.
Hello?
Yes, sir.
Okay, sir.
Yes, sir.
Yes. Now I'll stop this.
Yes, sir.
Shadab Ansari. Okay. Your name. Yes. So next, Anusha.
Yes, sir.
Anusha R.
Sir.
Next, Anusha R. Kaushik. Kaushik. Oh no. Vice
Present,
versa.
sir.
Okay. Akrut.
Present, sir.
Right. Next ಯಾರು ಒಂದು ನಿಮಿಷ ಹಾಗೆ ಹೇಳಿ.
Present.
got it. Darshan Kumar. Darshan.
Present.
Darshan Kumar. Okay, pa. Varsha.
Yes, sir.
1 minute. Anaga.
Present, sir.
Next. Others, you have to tell me. I can see only this many. Next.
Sir, Manish, sir.
Divya.
Yes,
One
sir.
minute.
Shri Vishnu.
1 minute. One by one. K ಅಂತ ಇದೆಯಲ್ಲಮ್ಮ ಕೆ ಎನ್ ದಿವ್ಯಾ.
ಹೌದು ಸರ್ ದಿವ್ಯಾ.
Next, Manish.
Yes, sir. Present, sir.
Manish, okay. Next,
Shri
Shri
Vishnu.
Vishnu.
Alhamdulillah, sir.
ಏನೋ ಇವಾಗ ಬಂದಿದ್ಯಾ ನೀನು ಕ್ಲಾಸ್ಗೆ? ರಹಮತುಲ್ಲಾ. ಏನೋ 9:00 ಬಂದಿದ್ಯಾ? Why?
Trial to bus, sir. Come to Bangalore. Come to college, sir.
You came to college,
Yeah.
Hello. Then you can attend offline class. Third hour it is there again. Are you getting?
Yes, sir.
Right. Next. That's all. How many are there now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Another one is missing, pa. Can I call names now?
Yes, sir.
Anaga, Akrut, Arvind, Rahmatullah, Darshan, Divya, Kaushik, Manish, Rupak, Shadab, and Shri Vishnu, Sugandhini, and Trupti.
Sir, my name is Varsha.
Name for Varsha. And Trupti is not there, I think, right? Trupti?
Sir, Anusha.
Trupti illa. Varsha ಹಾಕಕ್ಕೆ ಹೋಗಿ Trupti. Anusha ಎಲ್ಲಿದೆ ನಿಮ್ಮ ಹೆಸರು? Anusha. ಸರ್ ಆಯ್ತು ಈಗ 40. Okay. Thank you.
Thank you, sir.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.
I'll stop recording. Okay.